In the search for alien worlds, astronomers have uncovered countless mysteries. Hot Jupiters are massive gas giants that orbit perilously close to their stars. For years, these scorching planets were thought to scatter or consume their neighbors. But a recent discovery in the WASP-132 system is rewriting the rulebook on how planetary systems are thought to evolve. The TSA Space Telescope detected dips in WASP-132's brightness. This suggested the presence of another planet in the system other than WASP-132b, which has a 7-day orbit. TESS's observations result from the presence of a rocky planet within mass 6 times that Earth categorized as a super-Earth with a 24-hour orbit. The system also contains a third planet that is 5 times as massive as Jupiter in an orbital period of 5 years. Even though WASP-132 is cooler and less luminous than the Sun, the 2 inner planets are still tremendously hot. Much further out may be a brown dwarf with a mass of 18 times that of Jupiter. The presence of hot Jupiters near their stars is inconsistent with the nebula hypothesis because they could not have formed where we find them. Consequently, it has been proposed that they formed where they are supposed to and migrate inward to where they currently are. In the process, however, they would tend to either absorb or expel any smaller inner planets. The presence, however, of this inner super-Earth goes against this idea. One proposal is that the outer gas giant and brown dwarf may have an effect, but this is nothing but speculation. The discovery of new multi-planet systems like WASP-132 offers fascinating insights into the dynamics of exoplanetary systems, particularly those containing hot Jupiters. Hot Jupiters are gas giants similar in size to Jupiter but orbiting very close to their stars, resulting in high temperatures. These planets were once thought to be loners, without neighboring planets due to their disruptive gravitational influence during their migration. The detection of additional planets in the WASP-132 system challenges this assumption and indicates that hot Jupiters can coexist with other celestial bodies in the same system. This suggests that formation and migration theories are wrong. The presence of neighbors implies that the system has maintained a degree of dynamic stability despite the gravitational tug of a hot Jupiter. The neighbors might be smaller planets, such as terrestrial or Neptune-like planets, which can survive in stable orbits despite the massive presence of a hot Jupiter. Discovering multi-planet systems with hot Jupiters broadens our understanding of planetary systems. It challenges existing models of the formation and evolution of these systems, encouraging further study. One possible explanation for such stability is that they are not as old as current models assume and that there has simply not been enough time for the system to become unstable. In conclusion, existing models indicate that it is impossible to have a hot Jupiter along with smaller planets. This is because of the theoretical need for migration to save the nebula hypothesis from the existence of hot Jupiters. While some untestable patches may eventually be found to make it work, it is just another problem with the nebula hypothesis. If you like this content, please support this channel by making a donation or buying a product through the links mentioned in the description.